Hi there, this is
Exclusive hot.
Hi everyone, this is Rob, VK3BVW in Melbourne, Australia. Today we're going to have a look at an antenna which is called the double bazooka. It's been around for some time, but it's actually a new antenna for me. It was first designed in the 1940s at MIT in the US for government radar installations at that time. And then it became adopted and adapted by amateur radio operators from about the 1950s onwards. It's an interesting antenna, it's an interesting design, and I already have one up in the air, an 80-metre version, and we're going to have a closer look at the 40-metre version as well. This particular antenna comes from the IAC Antenna Corporation in America. So, let's go and have a look at it. Here's a diagram of the double bazooka, and it comes from N4UJW. You can see that it sort of looks like a dipole, but with some significant differences. So the antenna is made of coax cable, RG58, and on each end, on each leg, it also has 300 ohm twin lead. So in the antenna itself, in the coax part of the antenna, the sender conductor is not broken. That runs all the way through the coax cable, but the shield is split so that you have shield on two legs. You can also see that the center conductor and the shield at the end of the coax is attached together before being attached to the twin lead. Now the feed line is also coax. The center conductor of the feed line goes to one leg of the antenna attaching to the shield, and the shield of the feed line goes to the shield of the other leg of the antenna. So let's have a look at it and see what it looks like in its physical form. So here is the antenna as it comes straight out of its packaging. It also comes with printed instructions, and you can also download the printed instructions from the IAC website if you're looking for more information on the antenna itself. The cable is Belden, and it's RG58 cable. It looks to be a very good quality, as does the 300 ohm twin lead. The antenna is recommended that you set it up as an inverted V. And so it has an eyelet at the top in order to be able to do that. You can also set it as a horizontal dipole, but with the 40 and 80 metre versions, it's recommended that you have a messenger line that will help support the antenna in the air because of its weight. But we'll be setting this one up as an inverted V. Remembering that the antenna, or the coax part of the antenna, is really one piece of coax. The center connector of the coax is not cut, so it's running straight through there. It's the shield that's cut on both sides, and the feed line is attached down here, where the center point of the center connector of the feed line will go to the shield of one side, and the shield of the feed line will go to the shield on the other leg of the antenna. When you get to the point where the 300 ohm line is going to be connected, the center connector and shield of the coax are joined together, and then it's joined with the 300 ohm line after that. It's at this point here between the coax and the twin lead that can sometimes be a problem for home constructors of the double bazooka or of some other commercially available antennas. It's at this point here which the antenna will often break away. I don't think this is going to be the case with this double bazooka. You can feel through the plastic here where the join is. The whole area here is covered with quite a thick plastic sheath, and where the join is there and where the plastic sheath ends, there is quite some distance on both sides, which will allow for the support needed to make that connection last. There's also very good evidence of sealant, so that we won't get moisture through here, and there's also a moulded plastic end on the twin lead as well, which is also going to make sure that the antenna is nice and dry. So let's get back to the shack and we'll see how the antenna works. So the 40 metre and 80 metre antennas are now up in the air, and I've just put up a couple of quick pictures here to show you what they look like. And you'll see that they're at the apex of the antennas, they're surrounded by trees. They're probably about 9 or 10 metres up in the air. It's not very high at all, and they're in the inverted V configuration. And one leg of the 40 metre and one leg of the 80 metre antenna are both passed close to steel roofs. So they're certainly not ideal situations, and I'm sure that others can probably get their antennas up higher and more in the clear than I've been able to do here in these limited circumstances. But at least we can see in these limited circumstances what the antennas are capable of doing. We've tested the 40 metre antenna, and from a transmitting point of view, the SWR is really low, from 7 megs right through to beyond 7.2 megs in the Australian amateur band, so it works really well from that point of view. You can just plug that antenna straight into the transceiver without any antenna tuning unit or anything like that, and it'll work fine. There is no balun on this antenna either. It doesn't seem to need it, and it's not called for in the instructions, so we haven't put one in, and things seem to be working quite fine. There's no stray RF running around the shack or anything like that. So we've had some contacts on 40 metres, and it's worked really well. The reports have been very positive. Considering the height of the antenna, which is, as I said earlier, not very high at all, it's getting out extremely well. The antenna is also a very good listening antenna, and I do quite a lot of shortwave broadcast band listening, as well as my amateur radio transmitting activities. So the antenna has been very useful from that point of view. In the example that we're going to show here of on second for 7 megahertz, you'll find that we switch between a reference antenna and the double bazooka to make a comparison between the two. The reference antenna is a PAR end-fed SWL antenna. It's quite a common antenna. It's been around for quite some time. And you'll see that on some of the stronger signals that there's probably only about a 1 or 2 S-point difference between the two antennas. However, on weaker signals, the double bazooka can make the difference between having the station audible or virtually being bogged down in the noise. And while we're talking about noise, there will be a couple of clips that you'll see where the double bazooka is effective in actually quelling some of the noise that we hear on the band. So let's have a look at some of these clips, see what you think.
الشيخ هذا هو وتعالى. ثانيا الدنيا من وكالة الكلية أزاد وفيها أكثر في السن الشرط في الصلاة الشرط في الصلاة ويحتاج إلى النار النار والعلالة hasta la luz de la luna adelante estamos en el aire. ¿Está usted bien? Se quedó dormido, por lo visto. Hasta la luz de la...
So, there you have it. You can get more information on the double bazooka and other antennas by simply going to the IAC website, which is iacantennas.com. They're based in Pennsylvania, and they also have a very good shipping department. They had both antennas out to me here in Australia in double quick time, which was very much appreciated. Best of luck with your radio activities, and we'll look forward to seeing you again soon. This is Rob, VK3BVW, 73, best wishes.